So now in example 3, we have a sports example. So a basketball analyst for the New York Knicks wants to compute a team's shooting percentages. Okay, sometimes you're going to hear in sports, especially in basketball, like, oh, that guy's shooting 40% from three, right? Those percentages are important ways to compare players and understand how some players are doing better than others or whatever the case may be. So he creates a function rule that looks like this. So I'm going to break this down for you. This looks complicated, all right, but it's really not. The percentage, okay, that's what this sign means, percentage. So that's what we're trying to figure out. We're trying to figure out the percent. So this is the output, okay? The output is what is given to you after you do the function rule. So this is the output, okay? And the output is the percentage, okay? And the function rule that we're going to get is this. You're going to take the field goals, divide it by the field goals attempted, okay, and then multiply it by 100. So this is the function rule, okay, and the two inputs are right here. You have to input what the field goal number is for the person and the field goals attempted. You input those into this function that I have highlighted in yellow, okay, and then when you compute that using your Desmos calculator, whatever calculator you want to use, right, it's going to give you your output of percentage. So I've done a couple of these. I left 4 blank. Those are the ones we're going to do here in this video, but I have these available for you to check yours. You only have to do 4 on this page, okay? And these are all available to you except the blank ones, which I'm going to do now, so you can check your work. Let's do Julius Randle. So he's the best player for them currently. So let's do his. His field goals, okay, made, FG is the field goals made, and then FGA is the field goals attempted. So how many shots he's made versus how many shots he shoots per game, okay? So he makes about 8.2 of his shots every game, and he takes about 17.6. So we're going to use this formula here, this equation. Remember, functions are sometimes written as equations, and that's what we're going to see a lot in 8th grade math. Function is written as an equation. Okay, this is the function rule. Take the field goals, divide it by the number of attempts, and then multiply by 100. So we're going to do that. 8.2 divided by 17.6. Let's do that. 8.2 divided by 17.6, and then we're going to multiply it by 100. This is how you find the percentage of something. You take the amount that they made, right, divided by the total number of shots, and then multiply by 100 to make it a percentage. And we get this number here, 46.59. We're going to round it to the nearest tenth. So that's this number here, the 5. So I got to look to the number to the right to determine whether I'm bumping it up or keeping it the same, right? That's how rounding works. The 9 is a large number. It's 5 or above. So it tells me bump up. So I'm going to take the one that I highlighted, the 5, and I'm going to bump it up to a 6. That gives me 46.6% for Julius Randle, okay, which is pretty good, especially with volume. Okay, so if you guys know anything about basketball, the more you shoot, the harder it is to make a bunch of them. So when you're shooting 17 times a game and you're still making 46%, that's pretty good. All right, let's look at RJ Barrett. He shoots 14.9 times a game and he generally makes around 6.7. So 6.7 divided by 14.9. Okay, I'm just going to edit my equation here. So what it was, 6.7 and 14.9. So this is 6.7, and down here, 14.9. And we have a new percentage here, 44.96. So I'm highlighting the 10th place. That's the 9. That tells me look to the right. The 6 is above a 5. So that tells me bump up. Well, if I bump up a 9, that becomes a 10, right? So the 1 gets carried over. This is 45.0% if I round. Okay, so 45.0, which again is pretty good, pretty good. He's taking almost 15 shots a game and shooting at a 45% clip. That's great. Let's look at Derrick Rose. 4.8 shots a game at 11.3. So 4.8 he's making out of 11.3 attempts per game. We've got 42.47. So the 7 tells me to bump up again. That becomes a 5. So 42.5%. We'll do one more just so we can finish out this table. And again, guys, you will have all of this in this video. So we'll do 2 more. You'll have all of this in the video, so you can go and check yours. You don't have to choose the ones that I chose, right? I have all the answers here. Let's look at Immanuel Quickley. That's their new rookie this year. He's doing pretty well. He's making 4.0 on 10.2 attempts. 4.0 on 10.2. I'm just editing this equation now because I have it all set up here in my Desmos. You can do that, or you can retype it out each time. It just saves me time not to do that. Okay, so here's the 10th place. I'm looking next to it. The 1 tells me to just stay where I'm at. So 39.2 is where he's at, a little bit lower than those other guys, right? Which is typical for a rookie. Usually rookies don't shoot that great when they first come into the league, so it's not too bad. All right, let's look at Obi Toppin. That's their other rookie. All right, he's not shooting nearly as much. He's only making 1.7 out of his 3.5 attempts per game. 1.7 out of, what was it, 3.5? Yep. Okay, that gives you a 48.57. The 7 tells me to go up, bump that up to a 6. So 48.6%, which is really good. He's just not taking a lot of shots. But again, if you're not taking a lot of shots, sometimes your percentage is going to be higher. All right, so there's all of our percentages. This is what a New York Knicks analyst might use in order to determine, okay, maybe Obi Toppin, he's shooting at a really good percent, 48, but he's taking only 3.5. Maybe we need him to shoot more, okay? Or maybe, you know, we've got somebody here, 3.9 or 39.2 for Immanuel Quickley. Maybe he's taking too many shots. He takes 10.2 shots per game. Maybe he needs to take less. Right, so that's where a sports analyst might think through when they do this function to get their output. So here's all of our outputs. Our inputs were both of these things combined, and it gave us our output table right here. Okay, we'll see you in the next video.